Example 7. When does a bee population grow fastest? Population of honeybees raised in an apiary started with 50 bees at time t is equal to 0 and is modeled by the function p of t, which is equal to 75,200 divided by 1 plus 1503 e to the negative 0.5932 t, where t is the time in weeks, where t is in between 0 and 25. We're going to use a graph to estimate the time at which the bee population was growing fast, or fastest, then use derivative to give a more accurate estimate. Now the population grows fastest when the population curve y is equal to p of t has the steepest tangent line. So let's take a look at the graph here. So here we have our graph. We're going from 0 to 25, so let's put that in there. So we have 75,200, divide that by 1 plus 1503 e to the power of negative 0.5932, and we're going to call that x so it's on our graph. So let's go ahead and take a look at that graph here. Okay, so here's our graph, and it's saying here that from the graph of p in this figure, we can estimate that the steepest tangent occurs when t is approximately 12. So the bee population was growing most rapidly after about 12 weeks. So let's take a look at that. Okay, so when t is equal to 12, okay, let's scroll down here. So somewhere right around there at 12, okay, so we can see here, once it gets to 12, we can see that it's the steepest. So we could estimate this to be somewhere around approximately when t is approximately 12. Okay, now for a better estimate, we want to calculate the derivative, which is the rate of increase of the bee population. So let's go ahead and write this function out. So we have p of t. Okay, and we want to write this now denominator in the numerator by making this exponent to the negative 1 power. So let's go ahead and do that. So we're going to have p of t, which is going to equal 75,200 times 1 plus 1503 e to the negative 0.59, and I think that's 32t. Okay, I'm just going to bring this down just a little bit. Okay, and raise that to the negative 1 power. Okay, so now what we want to do is now we're going to find the derivative of this function. So let's find a derivative of this function. So if we find a derivative, that means that we're going to get this negative 1. So it's going to be negative 75,200 times 1 plus 1503 e to the negative 0.5932t, and that's to the negative 2. Okay, and then what we want to do is then we're going to multiply it by the derivative, which becomes derivative of what's inside. If we take the derivative of 1, it's 0. If we take the derivative of e, we have 1503 e to the negative 0.5932t. And then the derivative of the exponent of negative 0.5932t is negative 0.5932. Okay, and so if you look here, we do have a negative value, right? So that negative value is going to make this negative, this is going to be a negative times this negative, which is going to make that a positive. Okay, and so now if we multiply everything out, so if we take 75,200 200, multiply that by 1,503, multiply that by 0.5932, then we're going to get the following. We're going to get 67,785. Okay, and then that's going to be times 1 plus 1503 e to the negative 0.5932 t to the negative 2, and then times e to the negative 0.5932 t. And so therefore there is our first derivative. So now let's graph our first derivative here. Okay, so we're going to graph our first derivative. We have 67,046,785 times 1 plus 1503 e to the power of negative 0.5932 x, and that's to the power of negative 2 times e to the power of negative 0.5932 x. And so let's go ahead and see what happens on this graph. So we know that doesn't go above 20,000. So let's go ahead and change this to, let's say, 12,000. Our y value to be 12,000. Okay, so let's take a look at that value there. So here is what the derivative looks like. So if you take a look here, right, when we graph the derivative and observe that the first derivative has a maximum at around 12.3. So this tells us the maximum is at 12.3. And so now we want to get a better estimate. So to get a better estimate, we note that f prime has a maximum value when f changes from increasing to decreasing. So this happens when f changes from concave up to concave down. And that is, this is concave up and now it's concave down, when f has an inflection point. So let's compute the second derivative. So we want to find the second derivative using the first derivative. So let's go ahead and copy the first derivative here. We'll bring it down here. Okay, so what we want to do is we want to find the second derivative. So if we find the second derivative, we know that that's 67,046,785. Okay, and then what we're going to do is we're going to multiply it by the derivative here. So the derivative of 1 plus 1503 e to the negative 0.5932 t to the negative 2 is now going to become 1 plus 1503 e to the negative 0.5932 t, and that's going to be the negative third power. And then we're going to multiply that by the derivative of what's inside, which is 1503 e to the negative 0.5932 t. And then we're going to multiply the derivative of negative 0.5932. So negative 0.5932. So here we found a derivative of what's inside and then that one. Now we need to multiply it by the negative 2. So we're going to multiply that by negative 2 times e to the negative 0.5932t. And let me bring this over just a little bit more. Okay, so we're using the product rule, so it's going to be plus, we have 1 plus 1503 e to the negative 0.5932t to the negative 2 times e to the negative 0.5932t times negative 0.5932. Okay, so from here, we can plot this function to see where it changes from positive to negative, but instead we're going to solve this second derivative and set it equal to 0. So we're going to set this part equal to 0. So if we set this equal to 0, right, if we divide both sides by 67046,785, and over here the same thing, 67046,785, then what's left is the following. We're going to have the following that's left. Okay, so we're going to set this now do that here. Okay, so if we divide both sides, that means we no longer have this value here, right? And we know that this thing is going to be equal to 0. Okay, so now if we set this, we can subtract that to that side. So over here, we have this on this side, and then we're going to subtract this to the other side, which is then going to make this negative. So if we divide both sides by e to the negative 0.5932t, and divide this by e to the negative 0.5932t, and then divide by negative 0.5932, negative 0.5932. So what that does is, that's going to eliminate that to make that 1, and that's going to make that a 1, that a 1, and that a 1. So now what we end up getting is the following. So on the left side, we have 1 plus 1503 e to negative 0.5932t to negative 3 times 1503 e to negative 0.5932. And times negative 2 here. And that's going to equal negative 1 plus 1503e to negative 0.5932t to negative 2. Okay, so we can also notice that that minus sign here is going to make that a positive and make that a positive. So now, just to clear this up, now we're going to divide both sides by 1 plus 1503e to negative 0.5932t to the negative 3. And over here, 1 plus 503 1 plus 1503 e to the negative 0.59 32t to the negative 3. So here we end up getting 2 times 1503 e to the negative 0.5932t. And over here we have the same base. So that means the exponents are going to be negative 2 minus negative 3, which is plus, which is going to give us 1. So what's going to be left here is 1 plus 1503 e to negative 0.5932t. So let's subtract this to this side. So if we have 2 times 1503 e to negative 0.5932t and subtract 1503 e to negative 0.5932t, and that's going to equal 1. Well, if you have 2 here, that means when you subtract these, you're going to get one of them. So that means you end up getting just one of those, which is just 1503 e to negative 0.5932t, and that's equal to 1. So now we're going to be able to use logarithms. So we're going to divide by 1503, so we get e to the negative 0.5932t, which is equal to 1 over 1503. And then we're going to take the natural log of both sides. So if we take the natural log of both sides, so we end up getting negative 0.5932t, which is equal to the natural log of 1 over 1503. And so then in order to solve for t, it's going to be the natural log of 1 over 1503 divided by negative 0.5932. And so therefore t is going to be approximately 12.33 weeks.